What we're going to cover in this session is first a quick overview of Lambda. So I'll catch those of you who haven't used the service already or aren't familiar with it up on the basics. Then we'll talk a little bit about some of the recent launches and some of the new features that have been shipped in the last 3 months. And then in the second half of the talk, I want to transition to actually talking a little bit about serverless design patterns. So having covered some of the things that you can do with Lambda, I want to talk a little bit about how you can put it together with other AWS services or with third-party services to build these larger serverless design patterns for your applications. So let's go ahead and get started here. First of all, let's talk a little bit about what Lambda is, and also a little bit about what Lambda isn't. So it's the newest compute service from AWS, and what's different about it is that you don't have to think about servers. And if you've been an AWS customer, if you've used EC2 as an infrastructure offering, you're very used to thinking about all the things that you do with servers. You capacity plan for them, you stand them up, you provision them, you deploy code to them. With Lambda, you don't do any of those steps. Instead, you give us the code and we run it for you. And that has some interesting implications. Among other things, you can never be over or under capacity with Lambda. So there's no notion of not having enough servers to actually take care of the load that your clients are giving you. But you're also never over capacity either, which means, for instance, that you don't pay for cold servers or extra idle time that you aren't actually using. You only pay when you're actually doing something hot. Now that also means that if you don't have the servers, you don't deploy things to servers. That's a challenge that Lambda takes on your behalf. So you upload the code, Lambda makes sure it gets to the right machines and the right containers that it needs to be in order to operate. We also take care of the scaling and fault tolerance, and we'll talk a little bit as we go along here how some of that works. And then behind the scenes, of course, we're managing the servers on your behalf, and so we take care of things like keeping them up to date, making sure they're all healthy, updating the operating systems and language runtimes behind the scenes so you never have to see that. And then we build a couple of things in, like metrics and logging. So while you're free to use any third-party service you want, you can take advantage of ready-to-go built-in functionality for some of those mechanical basics. Now once you've gotten that, you can do all kinds of cool things with it. You can very quickly get code up in the cloud because it's highly productive. You don't have to do all those things that are listed on the left up there. And you can bring any code you like. So unlike some other systems that have been devised to be easy to use, that often have either curated libraries or a lot of restrictions, Lambda lets you bring any code you want. You can even compile C or C++ code down into native libraries and upload that as well. So we intentionally build a very robust, very flexible security policy to enable you to do all of that. Now the other thing that's really nice is that you can run code in parallel in a very easy fashion. So once you've uploaded that code to Lambda, every time you give us a request, we'll run it. And if you give us 1,000 requests a second, we'll run 1,000 different copies of your code all in parallel. So you don't have to be an expert in distributed systems or parallel programming or any particular framework in order to get the advantage of massive horizontal scale out. Lambda takes care of those challenges behind the scenes. And then once you've got that, you can do all kinds of things. You can create mobile and IoT backends, you can create event handlers for other AWS services, and you can create real-time processing systems. And we'll take a look at some of those in our design patterns. Now using Lambda is simple. As I mentioned, the first thing you do is you pick a language, and then you upload the code that you want to write. And you can bring any libraries that you want to bear for that. You write your code in the IDE of your choice, you can use the command line, and for the languages that are dynamic, like Python and Node.js, you can also author the code directly in the Lambda console. Makes it really easy to get started and write, especially smaller snippets of code, but you can use all of your existing build and deploy infrastructure if you've got an existing system. Now the programming model for Lambda is a little different than what you might be used to. While the languages are conventional, what you don't have is persistent storage on a server itself, because that server can change over time. So while we give you working memory and working disk space, it's all ephemeral. And so any persistent state that you want needs to get stored someplace else, like S3, DynamoDB, Kinesis, or some other persistent storage mechanism. You pick a power level that you want to use, and we'll talk a little bit about what that model looks like here. And then once you've done that and given us a little bit of information like the name of the function, you're ready to go. Things like logging, metrics, scaling, fault tolerance, they're all built in. And as soon as you've done that, it's all ready to go. Now, Lambda is just about a year old. And when we launched a year ago as a preview service at reInvent 2014, we had only a single use case, which was integration as an event handler for 3 other AWS services: Amazon S3, our blob storage, DynamoDB, which was then in preview form for its streams update to build triggers, and Kinesis streams. Now, a year later, we're integrated across the AWS portfolio with support for things like custom handlers in CloudFormation, support for message handlers in Amazon SNS that makes it really easy to build intelligent IT automation systems, and one that we're going to talk a little bit more about here, API Gateway. So API Gateway is another service, but it's a very, very close relative to Lambda, and people often use the two in combination. And we'll talk about that in some of the design patterns that we take a look at. API Gateway offers a fully managed system for hosting your APIs. So you can design your APIs on there, you can upload them in various forms, including Swagger definitions, and then you can manage different versions and different deployments of those APIs. So a very flexible system that takes care behind the scenes of all the challenges of doing that hosting for you, including, just like Lambda does for your code, the scale out and the fault tolerance. Now, it also gives you the tools to do a bunch of the management that you need to for your APIs, including things like deciding who can use it and how much they can use. So you can get network control over throttles, you get automatic built-in DDoS protection through CloudFront, and you have the ability to leverage a variety of different security models, including the identity and access management to authorize access to your resources. So lots of flexibility to decide who gets in that front door and how they're going to use those APIs. And then, of course, while you can use Gateway to go to anything you can reach on the web, including services you build on EC2 or third-party services out there on the web that are available through HTTPS, one of the easiest and simplest things to do is to couple it to Lambda. And when you do that, API Gateway functions as the interface, and you can think of Lambda as the implementation of your code. So the two work together hand in hand. Now I want to step you briefly through some of the things that we've launched recently, starting with the pre-reInvent launches back in September. We added 2 of our newest event sources for Lambda. First, the Simple Email Service, or SES as it's commonly called, which added support for inbound mail processing. And when you do that, the rules engine for that is built on Lambda, so that you can very easily decide which mail should be directed where, which mail should be rejected, and so forth. And I wanted to illustrate this in part because it's a great example of things you can do in your own applications. You can use Lambda as a way to provide a custom, arbitrary coded interface to your customers so they can extend and grow an ecosystem around whatever your application's already doing. It was very easy for the SES guys to take Lambda and add this arbitrary computing power, and their end users never have to suffer the burden of figuring out how to stand up servers, manage capacity, and so forth. So the ease of use that Lambda affords makes it really easy to build these computational ecosystems. Now, another one we launched back in September was CloudWatch logs processing. So you can actually do 2 different things now here. You can write Lambda functions which will send logs to CloudWatch. We'll take a look at that in our demo in a few minutes here. But you can also take logs regardless of where they came from and process them with Lambda. So if you want to do log indexing, auditing, transformations, search for various kinds of data, aggregate them, all of those capabilities you can do simply by hooking up your logs to Lambda. And Lambda will automatically impedance match. So as you write more things to the logs, more Lambda functions get spun up. As you stop writing things to logs, those functions get spun down. And so behind the scenes, all of that gets taken care of automatically. So moving on to October at reInvent, I want to step you through some of the things that Jeff mentioned in a little more detail. First, we launched support for our 3rd major language, Python, which is available in all of our SDKs and from the command line, as well as in the Lambda console. And we'll take a look at that in a demo very shortly. Now, one of the things we did with this is we also built in Boto 3, so that if you want to use Python to control other AWS services, that's really easy to do. You don't even have to bundle that library, it's ready to go. Of course, if you have any other libraries that you want to use, including native libraries, you're free to bring those as well. We extended the running time of Lambda from 60 seconds to 5 minutes. And this allows, especially some of our customers who want to do more heavyweight computations like video transcoding or large log file processing, to be able to handle those larger data objects and their computational requirements inside of Lambda. Now, I'm going to take a quick aside here to talk a little bit about the resource model for Lambda. So you heard me mention power levels and running time here. How do those two things play together? So Lambda offers a very simplified notion of resources. Instead of picking a type of instance, you tell us how much power you want, and you tell us that in the form of asking for memory. And you might choose to ask for more because compute power and memory move together in Lambda. So more memory equals more compute. If you turn all the way up to the highest power, 1.5 gigabytes, then you also get the maximum amount of computing power. Now, how do you pick? Well, if you've got an I/O task that doesn't do a lot of computing and that maybe is more focused on throughput than latency, you should set this as low as you can. Save yourself some money. However, if you've got a CPU-intensive task, then you might want to turn that up because you'll be able to get the job done faster for about the same amount of money. Or if you've got a bursty kind of task that's very latency sensitive, turning it up will give you the maximum amount of responsiveness. So you get to decide how you want to pick on that price-power continuum. Now, once you've made that decision, the price scales linearly with the compute power. So this is basically how you also determine the compute pricing for Lambda. And then we bill you based on your duration. And we offer 1/10 of a second duration. So you can run for as little as 100 milliseconds. And we round up to the next 100 milliseconds. So very, very fine-grained increments of compute time that you're buying. Now, that said, there's also a very generous free tier. You get 1 million free requests and 400,000 gigabyte seconds per month, every account in perpetuity. And so you have a lot of power there, a lot of requests that you can make. If you're a small development team, maybe you're working on an open source project, or you've got some trial projects at home, you can often do all of the work you want completely for free. And only when you move into production do you actually end up paying. Now, we also launched support for what was probably our most requested feature at reInvent, scheduled functions. Lots of people want to be able to use cron tasks, they have background tasks, overnight tasks, or they need to do something like pull an event source, maybe SQS or some other kind of queuing system, where they need to be able to do something repeatedly or on some kind of schedule. So scheduled functions make this easy. You can pick recurring functions, you can use cron syntax, and you set this up through the Lambda console. We'll be bringing SDK and CLI support for the same feature to market in the upcoming months. Now, today you can go down to 5 minutes of granularity. We'll eventually be reducing that to 1 minute. But if you need to get more fine-grained, that's actually not that hard. All you do is you write a Lambda function, and then you set a timer in the language of your choice, which can go off as often as you want. So you can actually spin inside that recurring timer at the language level and give yourself a finer-grained timer if you like. And then finally, we launched a feature that a lot of enterprises have been asking for, which is versioning. So API Gateway gives you the capability to version the APIs that you use, and now Lambda offers you the ability to version the code that sits behind them. Now, the development model remains really simple. Nothing changes if you don't want to use versions. It works exactly as before. Anytime you feel like it, you can upload code to Lambda, and the current version of the function changes to be the code that you've just uploaded. So super simple. But now let's say that you've gotten to a version that you like. You think that this is a really good version, you'd like to ship it out to clients, and you'd like to be able to allow them to keep using it. That's what we call publishing. So you publish a version which creates an immutable snapshot, not just of the code, but also of the configuration. So the power level that you pick, the name of the function, the IAM role that you associate with it to give it permissions to access other AWS resources, all of that gets bundled up into an immutable snapshot, and we give you a simple name for that, which is basically the function colon some number. So that allows you to give a client this representation for a specific version of the code. Now let's say you want to go a step further, and you want to define a mnemonic version. You want to define, say, the production version of your code or the development version of your code, but you want to be able to change it over time. For that, we implemented what we call aliases. If you've used symbolic links in Unix, then you know exactly how these work today. They're basically just a label, and you can decide which immutable version that label points to, and you can change it at any time. So you can now very easily do roll forward and roll backward with Lambda just by updating that version setting, and then Lambda will take care of the hard work of redeploying all of your software across the fleet to make that happen. Now, one of the really exciting things we launched at re:Invent was the support for our new Internet of Things service, AWS IoT. And that could be a whole series of talks in its own right, including some of the ones that are going on here today. So I'm not going to go into that in any detail. What I wanted to talk about was just the use of Lambda with AWS IoT. So one of the nice things about the way this works is that it's a lot like using API Gateway. So in this case, it connects devices which are sending data to the cloud to AWS Lambda. So when device information comes in, the message broker routes it. The rules engine decides if it's information that's interesting that should fire off some kind of activity. And if it is, then it sends it over to Lambda. And so you can build an IoT backend that runs in a fully managed way with no servers either for the processing and ingestion of the data or for the actual running of the backend code. And finally, we added support for the Tokyo region for API Gateway, which gives us now a complete trio of IoT, API Gateway, and Lambda in each of these 4 regions: Tokyo, Dublin, and US East and West. So we've got a complete stack of all 3 of those in each of those 4 regions now. And finally, we've been busy even since re:Invent. I want to tell you about a couple of things we've done here. So on API Gateway, we went back and added support for both the API and CLI. This is one of our most requested features because we launched initially just with console support. And this allows you to build full automation and deployment infrastructure around your APIs. So you can do things now like make a Swagger definition and then programmatically update that to create or modify APIs. You can also programmatically generate custom client SDKs as well as manage and monitor those APIs. So anything you can do in the console with API Gateway, you can now do programmatically as well. And we put an easy button in for cores. One of the things that we often see people doing is they set up cores, especially when they want to use API Gateway with Lambda to serve dynamic web content. And that took a few steps initially in the API Gateway console. Now there's a simple button that you just press it and it sets all the cores configuration for you automatically. So it makes it really easy to do one of the more common configurations. And then I want to mention just one more thing that we're currently working on, planning to ship in the upcoming months, which is VPC access for Lambda. So one of the most common requests that we get is the ability to access resources that are locked behind a VPC boundary, especially things like SQL databases, like RDS, Elastic Cache instances, private endpoints on EC2, and on all of those things that you put behind VPC for security purposes. And so we're working now on the VPC feature for Lambda, which will let you run any of your Lambda code inside of your VPC. So it'll have access to all of those resources. All right, I'm going to take a little break from the slides here and show you some of the new features that we brought to market. So here I am in the Lambda console. I'm just taking a look at the top level of the console, which lists all my functions. I'm going to go ahead and select New Function Creation here. And what this takes me to is what we call our Blueprints page. So while you can bypass blueprints, they offer a really easy way to get started. And they give you a set of templates for commonly used code. So when we added Python, we added a bunch of new blueprints written in Python to make it easy to use that language as well. So I'm going to show you one in particular here that we've designed to run in conjunction with our new scheduling feature. We call this the Lambda Canary. Now what the Canary does is very simple. It basically sets up a recurring schedule with a Lambda function, and it goes and checks whether or not a particular HTTP endpoint is alive and has a particular value in it, right? So it just gets that HTML page back, and then it looks to see if it can find a particular string. So here I am, I'm going to configure what we call the event source here, which in this case is a scheduled event. If we were building something else, like say an S3 handler, this would have us select the S3 bucket we want it to use. And this one's going to run every 5 minutes, so I'll go ahead and accept that. I'll give my function a name, and you can see here how easy it is to create a new function. The runtime here is set to Python 2.7, which is our newest language. And what the blueprint has done now, in addition to filling out the schedule, is it's filled out the code for us as well. And you can see, I think, everything except the final line of code here. So this is the entire code for the canary. And what it's going to do in this case is we've kind of pre-programmed it to pick our own Amazon.com retail site, and it's going to look for a particular string called online shopping. And every 5 minutes, it's going to go ahead and check and make sure that that site is still up and still possesses that particular string in it. So you can use this for the site of your choice, or maybe to set up a more elaborate canary that checks to make sure that your retail website is up and running, or that some other HTTP or HTTPS endpoint that you set up is doing what you expect. Now the code itself is very simple, but under the covers, Lambda and the scheduler events are going to make sure that this is highly available, fault tolerant, and can run as many copies of it as are needed. Now we're going to go ahead and complete the creation of this. I'm going to pick the role now. In this case, the basic execution role is good enough because we don't need access to a lot of other AWS resources. If we were going to use Dynamo, S3, or something else here, we would need to pick a role that would enable us to do all of that. And down here, we can select the power level. For example, I could turn this up a little bit, and then go ahead and move on to the final page. Now I'm going to let this set to be enabled later. We aren't actually going to sit here and wait for 5 minutes to watch this accrue. I'll go ahead and create the function. And that click is all it took to stand up a robust, fault-tolerant, scalable function in this region. Now we're ready to go. We can go turn this on if we want to get those schedule events. But instead, what I'm going to do is go ahead and test this now. So I'm going to go ahead and pick a schedule event sample. This just mocks up what a scheduler event looks like to Lambda. And then we're going to go ahead and send it to Lambda and watch what our function does. So I'll go ahead and hit the test button. And you can see it returns the result here, which isn't very interesting. It's just the input of the time from the schedule event. What's more interesting is what sits in the log here. So you can see that it actually went out and it checked that particular site, and the check passed in this case. And if we were to now go to enable this, we'd have a canary that, for as long as we allow it to keep running, will keep checking the retail site to make sure that it's functioning properly. Now if we back up, we can take a look at our function management page again here. I'm actually going to drill into this one more time and show you the monitoring. So this gives us kind of a quick dashboard. We can see that we've made some invocations, and we get some rough sense of the duration. We could also hop over to the CloudWatch service, and we can take a look at that same information here. So we could check out our Lambda metrics down here. This will be a copy of the dashboard with a few more controls for you to get a finer grained look. We can also hop in and take a look at the logs. So this is the same log that the console showed. And you can see it over here in the form of the log groups and the information there. So you can see the complete copy of the log here. And this, of course, you'll see regardless of whether or not you're working in the console or not. This is where the logs will always show up. All right, and then one more thing. I'm going to give you a quick look at versioning here. So what we've done so far is worked on the latest version of this code. And if we keep changing it, we'll keep changing the latest version. But let's say we like what we've just done. We can come in here and select Publish. We can give it an optional description. And now we've created version 1 of that code. Now we can hand out an ARN for this, a resource identifier, that will always and forever mean exactly that copy of the code with exactly that set of configurations. And we can go back to the latest and continue to make changes here. I'll just make some innocuous change. go ahead and save it. And now I'll publish again so we can create version 2. Now I've got version 1 and version 2, so I can discriminate between the two of them. And let's say we want to create a new alias here. So I'll go ahead and create an alias. We'll call this production, so we can define what production means. And I'll make that the latest version. So now we can see our alias, our production alias, which is pointing to version 2. If we go back to versions, we can see that is indeed where the alias is sitting. And we can also go in and change this. So I can go back to the configuration of this alias, and I could switch this to be 1 here, and simply by clicking on that, I've done a rollback. And behind the scenes, Lambda will wipe out all of the copies of 2 and recreate your fleet with all the copies of 1. And the next time you start making requests, you'll automatically get the old version again. So it's very simple now to do roll forward and roll back. Okay, I'm going to switch gears now and move into the other part of the talk. Having shown you a little bit about what Lambda is and some of the new features, let's talk about what you can do with it. So we'll step through a series of recipes here that illustrate some of the power of Lambda, particularly for building these serverless applications. So the first and probably the most obvious one here is that you can build backends for mobile apps, IoT apps, web apps, in a way that is completely scalable and also serverless. How do you do that? Well, for mobile apps, you will use the AWS Mobile SDK, and you can optionally use Amazon Cognito for authentication, and that takes care of the client side on the device. For IoT, you would use IoT clients, and then of course you would configure the AWS IoT service as well, and set those rules engines up that I showed you earlier to point to your Lambda code. In Lambda, you can go to that blueprints page and pick the mobile backend blueprint. And we'll take a look at that in a second here in another demo, and you can see what that looks like. And then you need a place to store your data. So DynamoDB being an obvious one where you can place your data, especially for CRUD type services. Very easy to use, scalable, NoSQL database. And with those 3 things in combination, you've now got a backend that can scale from your development days all the way up to a full-scale production deployment without you having to change any of the code or any of the configurations. It's all ready to go. So that distance between, hey, it worked once on my box, it's functionally complete, and it's ready to roll out to production to our customers, vanishes. All those challenging things that stand in the way, like setting up monitoring and logging and going back and worrying about, do you have enough capacity? What happens if you get a burst of customers all at once? All those become AWS's problems, and you get to just focus on the code. So that was mobile and IoT. How would we change this for web apps? Well, we bring 2 additional things into the mix here. One of them is S3 for serving static content. So this is a feature we've had for a long time. You can put your media and other static assets in an S3 bucket, configure static website hosting, and then you can serve those up out of there automatically. And S3 will take care of the hard work of doing that for you. Again, totally serverless, doesn't require any infrastructure. And you can optionally stand up CloudFront in front of that if you want to do caching across the world on a per pop basis as well. Now that